Hello everyone. In this video, I will show you how to calculate gas well deliverability. Having built the fluid model, the next task is to construct a simple gas well using the information provided. First, let's go back to our Part2 software and click on well. So we are going to use the parameters provided to build the completion model. So first we start with tubular. So under tubulars we have simple and details. Details include the different types of casing such as conductor, surface, intermediate, production and liner. But simple only uh, represents casing and tubing as a whole. So we are going to start with modeling the completion using simple um, completion model. First we enter. Let's look at the parameters for the depth of casing is 2000, 11,200, 11,200. So we enter here 11,200 and the diameter is 8.681 and the thickness is 0.472. Then the roughness remain constant. We click on plus to bring out the tubing. Tubing depth is 10,950 feet. Then the is 3 point, diameter is 3.46476. Then the roughness is 0.262. No, the thickness, sorry, wall thickness is 0.262. Then the roughness remain constant. The next is to click on the downhole equipment and enter packer depth to be 10,000 feet. And then the next is to click on heat transfer. Heat transfer and enter under soil temperature at well 830. The heat transfer coefficient remain constant or at default. The next is to click on completion and enter mid perforation depth. Mid perforation depth. Before you enter, click on plus and click the mid perforation depth to the 11,000 depth or 11,000 feet. Allow the IPR model to remain. Later we change it to the test data or the back pressure. So enter the reservoir pressure 4600 and temperature to be 280. Then change it to gas, don't forget, and the gas flow rate, enter 1 minus 0.6. Next, click on the float. Upload the float you created in the first video and make sure your validation shows green, showing that everything is correct. Once you confirm that everything is correct, click on the PB/T profile, that is pressure temperature profile, and enter changed here from liquid flow rate to gas flow rate, and enter wellhead pressure or outlet pressure of 800, and then click calculate or run. Once the simulation has completed, you can now see your flow rate, but click show grid. Now you can see all the parameters, the pressure, temperature, float model, liquid loading, liquid hold up, and then you can see the the different flow regime. Sludge flow is present. So next let's look at the results. Click here, type filter, and click completion. Click 1 here to see the static pressure, the bottom hole flowing pressure, see the static wellhead bottom hole temperature, then you see flowing bottom hole temperature, then you can see liquid rate, gas rate, mass rate. Alright, so the next we are going to calibrate this model. So to achieve that, let's go back to completion. So click well and click reservoir. Under reservoir, you click on the box here. First, let's go and change the IP to back pressure. Good. Now you enter the test point 9.7. The next one is 11.9. The next one is 14.3. Then with their corresponding pressure, first one is 3000. The next one is 2500. And the last one is 1800. So now you can see that your points have been plotted. See the first point, the second, and the third point. Now the next is for us to rerun the PT pressure, and we can capture this result. Let's capture this result so that we can compare after calibration. See the results before calibration and the results after calibration. So we can capture this value. Let's just create something and put it here. Later we remove it. All right. So we want to see, we'll compare them. All right. So let's go and run simulation. Run it again. So let's check. Click on the show grid and click on the completion. Click 1. So let's capture these results and let's capture the result and see and compare the results when we calibrate and when we did not calibrate. So let's go back here. So you can see the results when we calibrated. It's the second one here. Okay, this is the one of we have after the calibration. This is the result. Before we calibrated it, this was the result. So you can see that there's a difference in almost everything. The the gas flow rate, and then the gas flow rate is higher in the uncalibrated model than on the calibrated model. So now let's look at the calibrated model and know whether the fluid is turbulent or laminar. How do we know whether the fluid is turbulent or laminar? We can go back to weld, see the reservoir. The condition for laminar is if the constant slope end is equal to 1. That shows that the float is laminar. If it is 0.5, it shows that, or less than 1, it shows that the float is turbulent flow. So this is where we can stop for now. The next video will be how to calibrate. Sorry, the next video will be how to will take us to selection of optimum tubing size. Thank you.